This video is one of a short series of videos on properties and phases. We have 4 problems here, and I'm going to use one video to solve one problem each. The first one, what is the internal energy of R134A at negative 10 degrees Celsius and 140 kilopascal? Now, when you have such a problem, you have a system that you know pressure and temperature, and you want to determine the internal energy of the system. You first need to know what phase is the system in. So we have our system. Let's call it my system. My system. My system is a R134A. It's a refrigerant. That's the substance that composes the system is made of, and we have the pressure and temperature. We know the temperature is negative 10 degrees Celsius. We know the pressure is 140 kilopascal. So that's what we know about our system. This is our system. We first need to determine the phase of the system. So we look for what I call a saturated system to saturated fluid system. Then we compare our system, my system, with this saturated fluid system. Let's say the saturated fluid has a temperature of 10 degrees Celsius, and it should have a corresponding pressure P sat. So we're going to determine, we're going to first find the P saturation for the saturated fluid system, and then we do a comparison between these two. Based on the outcome of that comparison, we can tell what phase my system is in. Okay, so I use a saturated refrigerant 134A table, and we use the temperature table. This is the temperature table. And we look for the temperature, minus 10 degrees Celsius. Okay, then the second column is the saturation pressure. So we found it's 200 kilopascal, 200.74 kilopascal. So that's the pressure of a saturated fluid system of 134A at a temperature of negative 10 degrees Celsius. So this here should be equal to 200.74 kilopascal. Now let's do the comparison. We're comparing my system with the saturated fluid system. Since they both have the same temperature, we compare the pressure. The pressure here, you see 140 kilopascal, that's the pressure of my system, is smaller than 200.74 kilopascal. So my system's pressure is lower than the pressure of a saturated fluid system at the same temperature as my system. Okay, these two are the same. If you remember what I'd said in the classroom, if you have a saturated fluid system and you compress that saturated fluid, you increase its pressure, you will get compressed liquid. Okay, so if my system's pressure was higher than the saturation pressure, then my system would be a compressed liquid. However, here my system's pressure is lower than the pressure of a saturated fluid system. Because my system's pressure is lower than the pressure of a saturated fluid system at the same temperature, so my system must be a superheated vapor system. Then what I need to do is I need to go to the saturated, the superheated vapor table for R134A, and find the property of that system. Alright, now I have found the superheated vapor table for R134A, and I look for the correct block in such a table to find the information I need. The blocks are classified. Each block represents one particular pressure. Okay, because my pressure is 140 kilopascal. That's 0.14 megapascal. So this is the block that I need to go to, and then I look for the pressure. I look for the temperature of my system. My system is at negative 10 degrees Celsius. So it's this line. And what I need to find is the internal energy of my system. And this is the internal energy of corresponding to such a condition. Now, in some cases, you may find that you need interpolation. Now, interpolation is a separate issue. I have a video that talks about interpolation. If you need help with interpolation, please look for such a video. Okay, so we found the internal energy of the system, 225.9 kilojoule per kilogram. Okay, so let's come back to our problem. My system is a superheated vapor system of R134A, and using the superheated R134A table, I found that the internal energy of my system, the specific property, the specific internal energy, or the intensive property, it is equal to 225.91 kilojoule per kilogram. So let's review this process. In this process, we first determine the phase of the system by comparing it with a saturated fluid system, and then we decided it's a superheated vapor system, and then we go to the superheated vapor table to find the information we need.